Alright, so today we're going to work on taking apart a desktop. Trying to keep everything nice and organized. It's a magnetic tray for screws. Take the side off, thumb screws. Alright, so we've got our hard drive. That's where our operating system is stored. DVD drive, Blu-ray drive. This is a DVD RW. We have our 24 pin P0. Our CPU fan, heatsink, RAM, and this one has no CMOS battery in it. You just use this one for teardowns anyway. So the first thing we want to do, get out the right screwdriver. This one's going to take a fairly large Phillips bit. Largest one you guys have, I think. That's some tri-lobe. So one of the first things we want to do is take apart, get all of our SATA cables disconnected. Now these in particular, the red one anyway, has a push button on it, so you got to push the button to get that out. Set that to the side. We unplug our SATA cable, SATA connector from the hard drive. That one's got a push button, and this one has a push button. So as you can probably tell, I've already taken off the back side. That's already open. So we want to push the button on the side of the 4-pin for the voltage regulator module. Extra power for the CPU. So we'll push the button on here. 24 pin, then we can take the power out of the DVD drive. So on all these power supplies, you're going to have 4 Phillips head screws in the back holding the power supply in. Not every power supply is like this, but for the most part they are. Some of the more expensive cases, you'll have like a little latch that comes down, holds the power supply in place. Typically they're screwed in. These are the same type of screws you screw the motherboard down with. It's a hex head on top and just Phillips in the center. So take these, put them in our storage. We'll be able to slide this out. You guys notice I'm not wearing a anti-static strap.
Yes, sir.
This table is anti-static. I'm constantly touching the case to ground myself. So I'm going to set the power supply at the side. Next thing I want to do, I'm going to go ahead and pull the hard drive out. This one only has 2 screws in it. It should have 4, 2 on each side. Some of the desktops you'll see, they'll be what's called toolless, where you won't have to have a screwdriver or anything to pull anything out. They'll have little clips in place. You can flip a switch. You can see all these screws are the same size and be able to slide the hard drive out, slide the DVD drive out. Set these things to the side. So now we can go ahead and get the screws out of our DVD drive. So these are a little bit different. It's a little finer thread there. Yeah, you can tell this thing's been taken apart before. They never put all the screws back right. So I'll take these 2 screws out. These are the only screws we have that are like that. And this will just slide out the front. Set it to the side. Here's our speaker. We'll pull that out from the front. This type of case has a front that just snaps off. Pull it from the bottom. And it's got a bunch of little snaps in it. Just held in place by pressure. Like that. Then our front panel for our USBs and our audio, we've got a microphone port, a headphones port on the front. Then we have our power button, reset button, and then the hard drive activity LED light and the power LED. These plug directly into the board. So we just unplug all of those at once. They're all labeled, right? So your white is going to be the negative side, and the red will be the positive side. It's not too big of a deal when it comes to your power switch and your reset switch, because they're normally open switches. So whenever you hit the button, it just bridges those two contacts and powers the machine on or resets the machine. But whenever it comes to your LEDs, having the right polarity is crucial, because if you wire LED backwards, it'll burn it up. And we have our speaker wire. This is for our USBs. And this is for our audio. So now we can remove the entire front panel. A little dusty. Sit it to the side. Now these do go out. Your buttons do. So you could have a perfectly good working computer and just the button is bad. So one of the ways we test that is just unhooking the power button, and then you can take a screwdriver and figure out on the board, it usually says which one's which, and then just bridge those two contacts together, and if the machine comes on, you know you got a problem with your button. So here's our speaker. It has two little push tabs here. Take that out. These go bad as well. So now we've got our case fan. Unhook it from the motherboard. Most time your case fan is controlled speed-wise by the motherboard. So if the machine starts getting too hot, it'll increase the speed of the fan. There's one thing you want to pay attention to is always make sure that the fan on the back of the case is blowing out. Almost every computer fan will have directional arrows on it. It'll tell you which direction it spins in and which direction it's blowing in. The easiest way to tell by looking at it is where the bracket is. If you have where the bracket is, that's actually holding the fan motor and the bearings that the fan spins on. That's the direction that the fan's blowing. I've never seen one that was wired or created differently. I'll show you what the directional arrows look like on this one once I get it out. Now your fan screws are going to be a little bit different. They're pan head, flat on top, but they're really coarse thread. So it's a little different. So then you can see here's your directional arrow showing which direction it's blowing in. So it's blowing air that way, and it spins this way. So the arrow's going this way and this way. You can see where's your bracket, fan's blowing that direction. So the fan is blowing toward the bracket. Now if I'm just removing the board, I will typically leave the CPU, fan and heatsink attached. That way I can just pick the board up by the fan, by the bracket. That way I don't have to actually touch any of the parts on the board. Keeps me from accidentally shocking it. Static electricity will kill one of these. So we remove all the screws from the motherboard. And the motherboard is held in place by screws and what's called standouts. The standouts, little brass, plastic, or sometimes just regular steel pieces that screw into the back part of the case. So it shows it's a motherboard's Asus P8 LX2 version 2 1155 socket. So this is a Intel, just by looking at the numbers on the board. Like I say, this is anti-static table. The entire tabletop's anti-static, so we can just lay that down. Now this is your I/O shield. What this does is it covers up everything except for what's actually coming out the back of the board. keeps anything from crawling inside the board. But it also helps for airflow. Airflow is pretty important inside a computer to keep it cool. So those are probably the screws that belonged in the hard drive. They just didn't get stuck back in there. Alright, so that's how you take apart a desktop. Now, all of the standouts do actually come out. You can take a nut driver and remove them. These are all in there pretty tight, or just a wrench or a pair of channel locks or something like that to remove them. But as far as tore down, this is about as tore down as you can get. Everything's removed from it that's electronic, and now we just have the frame of the case. So whenever you guys have to tear these down for class, I make you take out everything. So we're going to remove, this one's dusty. I'm not going to remove the fan from the heatsink. I will unplug the fan, of course, from the board. But I'm going to just unscrew the heatsink from the motherboard. Because if you take the fan out, what we found over the years is taking these things out, the aluminum for the heatsink tends to come off. And as the threads are going back through, whenever you're putting the fan back on, and it has a tendency to leave little pieces of aluminum scattered across the board. And it's the last thing you want, something that's conducting electricity that's not supposed to be on your motherboard. Then you won't have a motherboard anymore. So just unscrew that. And it should be just about free from that back plate. Now, in AMDs, this is a really big consideration because of the way AMD processors go into the socket. But with Intel's, it's not really that big of a as big of a deal as it is with AMD. With AMDs, you want to just spin the heatsink a little bit to make sure that you're broken free. Because with AMD, you can actually pull it clean out of the socket. If you don't break that adhesion, because there's an adhesion between the thermal compound and the bottom of the heatsink, and where the heatsink is actually attached to it. And the thermal compound is there to bridge the gap. Because if you look at the surface of the CPU, the heat spreader on top of the CPU, microscopically, it's really rough. Think about like mountain ranges. So what the thermal compound does is it actually fills in all of those gaps in between the rough surface of the heatsink and the heat spreader on top of the CPU die. So now we can remove the RAM. It's DDR3. Like I said, this is all anti-static. Typically, if I was going to do this for a customer, I would be putting everything inside a anti-static bag. Like I said, this is all anti-static. The entire surface is. I'm literally just laying my arms on it. So this has a gate that closes over the top of it. So we'll push that down, kind of pull it to the side a little bit, and then that'll lift itself up as we can remove the CPU. One thing about Intel CPUs that the majority of AMD doesn't have, some of their later server grade stuff does, is the two little notches right here on the side of the CPU. So you literally can't put it in the wrong way and it won't fit properly. So those two notches line up with two notches in the CPU socket to make sure that all of your LANs touch properly, to get good contact. So this is tearing apart a desktop. Very simple desktop, not just a whole lot of fancy stuff in it, no water cooling or anything like that. So we'll just put it all back together. If I pick it up, the bracket may come off the back. I'll just lay it down and show you guys that. This is the bracket on the back. Most of these are glued in place, so they won't come off. If you're using the aftermarket stuff, there's a very good possibility that it'll just fall off the back of it. Just lay that there. You can see my notches here. I'll line that up inside the socket. Do your best not to bend any of those little pins. So the difference between AMD and Intel is AMD is what's called PGA, or pin grid array, and Intel is LAN grid array. So you have LANs actually on the CPU and all of your pins are inside the socket, whereas with AMD all of your pins are on the CPU and all of your sockets it actually drops into a socket in the motherboard. So that's in place. One of the things I like to do is kind of wiggle it around a little bit just to make sure that it's seated properly. You don't want a corner sticking up where it shouldn't be. And we'll lay this back down, make sure that it slides up underneath the screw, push this arm down, and lock it in place. So now the CPU is in place. It's making contact properly with the socket, and we can set our heatsink back in place. Now, a lot of the purists will say with factory thermal compound, you want to take that off, clean it off really good with alcohol, and then put new thermal compound back on. But this, like I say, this entire machine is just for teardowns. So we're just going to put it back together. It really wouldn't hurt anything because we didn't really move that much, and we didn't create any gaps. So if you have gaps between your thermal compound and your CPU, like big spots where there is no thermal compound, you'll create heat spots. So the CPU die will start getting hot in certain spots, and of course, if your CPU starts getting hot, the heatsink can't cool it off as well as it should. Your performance will suffer because the motherboard will just slow it down. Thermal clock it, so you won't have nearly as good a performance if the CPU is starting to get warm. Frequency scaling. So I put this back on the same way, and one of the reasons I did that is so that we don't have just a whole lot of extra CPU power cable or fan power cable sticking out. It's kind of taken up by the side of the heatsink. So as you see, as I'm touching the RAM, I'm only grabbing it by the sides. You never want to touch the contacts, never want to touch the chips. Even though I'm grounded on a anti-static mat, there's still possibility of having stray static electricity. So never want to actually touch the chips. We'll set that down inside the socket and push that in place. Most of the time, the little tabs on the side will come up as you push it down. Sometimes they don't. This is DDR3. With DDR4, it actually has a beveled edge. The card edge is beveled, so you're not trying to push apart all of those pins at one time, because you have quite a few pins in there that have to be spread apart. That makes contact on both sides of the chip. So with this one, you just have to press down. I always try to do this on a flat surface. I never want to build the machine back and then have to install the RAM inside the desktop, because you have your standouts here, here, and here. Whenever you're pushing this RAM down, you're actually flexing the board. So you want to lay the board on a flat surface to be able to install the RAM. So RAM's back in, CPU's back in, heatsink's back on, everything's tightened back down, and we never removed the fan. We just removed the heatsink as a unit. Now we can install everything back inside the case. So I always want to install the motherboard first. Before we install the motherboard, we have to install the I/O shield. So we'll just set this to the side. Make sure the I/O shield goes back in properly. So it has, of course, everything's labeled there on the bottom. You have DVI, and then your VGA, your audio ports, and Ethernet. It has a lip back here. The lip stays on the inside. Just lay it in. I used to do the bottom side first. Make sure I've got it in place. I'll just push it in until it bottoms out all the way around. Alright, so that's back in. So like I say, we pick up the motherboard by the heatsink. It's bolted directly to the board. Lay it in here. And then slide all of your components back out through the I/O shield. Make sure everything goes out the way it should. And whenever you're bolting the board back down to the case, you never want to You never want to tighten the screws all the way down until you have them all in, because you're going to have to move this around just a little bit. The I/O shield has a bit of a spring to it, kind of pushes back against the components. So we'll just start the screws. And this is a magnetic tip screwdriver. A lot of people say you shouldn't use magnetic tip screwdrivers to work on computers. As long as you're not laying the magnetic tip on top of a chip, it should be fine. So as you can see, I'm putting in the ones on the furthest away from the I/O shield first. So these standouts, they do something really important. Actually, a couple of things that are really important. It keeps the motherboard from touching the bottom of the case and being grounded out against the metal. But it also grounds the board in those certain places. So your screws and your standouts are pretty important because it actually grounds the motherboard to the case. Tighten that one up, this one up. And you guys can see how much the board, it flexes. You can see it move as I'm pressing down. If I was trying to install RAM now, that RAM would be flexing the board really badly. Alright, so the board's back in. Make sure I/O shield, nothing's covered up. You have these little pins on the top. Those are supposed to be up. Sometimes I've seen where they've been installed, they actually slide inside the component. And the student's already got the computer back together and go to plug something in, and it's got a little piece of that I/O shield stuck in the way, so they can't actually plug in like the VGA cable or something of that nature. So we've got motherboards in, RAM's back in place, CPU, heatsink, everything screwed down. So next we can put the speaker back in. I'm not going to hook this back up yet. So I want to make sure that I've got everything else in place first. I'll go ahead and flip this over. It's on the other side of the case. Put the bottom in first, and put the top in. Wire management is pretty important. We want to make sure the wires are put through in a really easy to get to spot, so that if we have to take them back out, we can fairly easily. But also for airflow, you don't want your cables touching a fan. They'll get inside the fan and cause a lot of noise, stop the fan from working, a lot of things. So slide those through, and go ahead and push our case back in place. There we go. Nice and neat. Back over. Then I always try to plug these in first. Sometimes I'll take the motherboard and lay it on the side of the case so I can plug these in because I can see it a little bit easier. So there's your hard drive LED, it's your power switch, then your power LED and reset switch. But these are actually pretty easy to see. So just me move my USB and my audio out of the way. So my hard drive LED, and it's labeled which one's which. You have a little positive sign beside the positive side. My power LED is the same. Positive on the far side, negative right beside it. So then we have our power button and our reset button. So I'm going to put the reset button on first. It's closest to the bottom of the case. our power switch. So that's in. We can put our speaker on. All right, so speaker's in place. Now this is our USB. In some cases, we'll have a little clip down at the bottom, on the bottom of the case to hold these wires down. This one does not. And here's our audio. So if you guys look at the bottom of this, it has, of course, pins all the way across the bottom, but then it's got one blank spot where there is no pin, right? That should line up with the motherboard. And if it does, I mean, you can look at the motherboard and see that you're actually missing a pin in that one spot on the board. So that's where that lines back up. All right, so all that's in. Well, what do you want to do next? Let's do our fan. Put that in place. Make sure all my screw holes line up. Make sure it's going the right direction, right? So the bracket's in the back, it's pushing out. So ideally, we want to try not to fight physics. Heat rises. So a lot of the more expensive cases, the gaming computers, things of those nature, they'll have fans across the top. So as it pulls cold air or cooler air in from the bottom and the front, it exhausts it out the top. But this is just a standard SYX business type computer. This is skipping across the top. Could you give me a larger Phillips head? Should be one on the table back here behind it. So this is fine for the rest of the screws, but these other ones have a little bit bigger socket. Now, as you guys are going through and doing this for your teardowns, if your fan's going the wrong direction, I will take points away from you. So just be aware of that. Then we have a chassis fan plug on the board. We still don't have a CMOS battery. If we were booting this machine up to use it for something, we'd need to put a CMOS battery back in. But just for teardowns, we really don't need it. And go ahead and bolt our hard drive back in place. You could slide it all the way forward. It has three screw holes in it. This one, it won't. The case is too short, so we have to slide it in there. Let's see. So this has a place for screws on the other side. We're short some screws on this one. But if I was going to put this in to be used for customer or end user, I want to make sure that we put screws on both sides. Hold the drive in place more firmly. Just slide that in. It should be flush with the front of the case. Your screw holes lined up. And the ones for your DVD drives, they're a finer thread than what the hard drives are. Now, solid state drives usually have a finer thread on the bottom, and then the rougher thread on the sides. flip this over. All right, so now we have our hard drive in, DVD drive is in. Now we need to put our, can go ahead and plug up our SATA cables. We want to try to keep the power supply out of the way. So most motherboards, and this one's no different. Most motherboards will have some ports, some SATA ports that are SATA 2, and some SATA ports that are SATA 3. This one actually only has one SATA 3 port. So SATA 1 is 1.5 gigabits per second, SATA 2 is 3 gigabits per second, and SATA 3 is 6 gigabits per second. So you always want to make sure that your hard drive is plugged into the fastest port, because that's where your operating system lives, and that's where your games, applications, whatever it is you're using, is actually reading from the board. And your DVD drive, Blu-ray drive, it doesn't get used nearly as often. So you can plug it into a SATA 3 port or SATA 2 port, and then we'll plug our hard drive into a SATA 3 port. So you want to get as much speed out of our All right, so we've got our hard drive plugged into a SATA 3, DVD drive is plugged into a SATA 2. So those two are plumbed in. Now all we like is our power supply. Lay it back in place. Got them backwards. I'm gonna put it in this way. Typically your wires come out to the back of the case. Now, one thing you may want to think about whenever you're building a computer, putting everything together, is if you have a nice aftermarket power supply, a lot of them, this one has an 80 millimeter fan in the back. Those aftermarket ones, they'll have a 120 millimeter, 140 millimeter. If you're putting it in, you want to make sure that it's actually pulling air from inside the case and that it's not stuck up against the top of the case. A lot of those, they will have the nicer cases, nicer power supplies, they'll have a spot on the bottom and the motherboard will be at the top. So your power supply will be at the bottom, the motherboard will be at the top, and a lot of the nicer cases will have an opening at the bottom to be able to draw cool air in. That way you can cool the power supply from outside the computer case instead of from inside where all the components are creating heat. Make sense? Mm-hmm. So now we can spin this back around and go ahead and plug in our DVD drive, SATA connector. Get our 4-pin in place. Now, if I was building this to go into a office something of that nature, I would go through and make sure the cables are all nice and neat, zip tied or Velcro strapped back out of the way. Let me push that down and kind of wiggle it back and forth as you're plugging it in. And you guys can see how that motherboard or how that hard drive moves. Those other screws aren't in there. I have 2 extra over there. I'll put those in. Everything's kind of out of the way. If I was building this, instead of just doing this for the demonstration, I would clip this and then tie back all of my power wires back here in the back. That way they're not too close to the CPU. So go ahead and flip this over and put those screws in the other side of the hard drive. I only have one. That one's a different thread. This will tighten it up quite a bit. And that is how you tear down and rebuild a desktop computer. With these, they have little notches in them. Here, here, and here that have to hold it in. Just make sure when you're putting the side back on, those go into place nice and flat, and then slide the entire thing forward. You have a spot here on the back to put a lock on. That way you can lock it, keep anybody from taking the case off and doing anything odd to the inside of it, stealing something out of it, or trying to bypass passwords, things like that. So that's it.